Remember that there are three ways to prove that triangles are similar. So we have angle-angle similarity, side-angle-side similarity, and side-side-side similarity. So we're going to use those to identify similar triangles and solve for missing variables. So number one, we need to write the similarity statement and state why the triangles are similar, and then solve for x and y and find the scale factor. So we have two triangles in this picture. We have our little yellow triangle, which is BCD, and we have our bigger triangle, which is ACE. So in this case, we know that C is congruent to itself by reflexive property because they have the same angle in both triangles. We also see that BD and AE are parallel lines, so B is congruent to E. So in this case, we would say that triangle BCD is similar to triangle ACE by angle-angle similarity. So now that we know that they're similar, we need to solve for x and y. So we have our little triangle and our bigger triangle. And in the bigger triangle, we need to find the two sides that are slanted because right now they're broken into pieces. So we see that the side AC has a length of 39 and that CE has a length of 10 plus y. So to look at my sides that correspond with each other, 24 corresponds with the whole side length on that side, so 39. 10 corresponds with the side on that whole length, which is 10 plus y, and x corresponds with the other base of the triangle, 52. So now we can use those ideas to solve for x and y. So both times we're going to use 24 over 39 because those give us side lengths. And then to solve for x, we would have the x from the smaller triangle over the side from the larger triangle, which is 52. And now we can solve for x by using a proportion and cross multiplying. So we get 39x equals 29 times 52, which is 1,248. We can divide both sides by 39, and we get that x is 32. Then to solve for y, we're still going to use the 10 over 39 because they both have numbers. And that way we can make sure our equation only has one variable in it. So to use the y, we have the side from the smaller triangle, which is 10, over the longer side, which is 10 plus y. So when I cross multiply, I get 24 times 10 plus y equals 390. We're going to distribute the 24, so we get 240 plus 24y equals 390. We can subtract 240 from both sides. So we get 24y equals 150. When we divide by 24, y is 6.25. Then to find scale factor, remember that scale factor is your new triangle over your old triangle. So based on our statement, ACE is the new triangle and BCD is the old triangle. So the side from ACE is 39 of our new triangle. And the side from our smaller triangle that corresponds is 24. And we can reduce that by dividing both numbers by 3, and we get 13 over 8 for our scale factor. Number 2, write a similarity statement and state why the triangles are similar, then solve for x, y, and find the scale factor. So in a bow tie problem, remember that you always have vertical angles that are congruent. We also know that if RY and IL are parallel lines, using a transversal, we can say y and I are congruent because they're alternate interior angles. So we would have triangle YER is similar to triangle IEL by angle-angle similarity. So we need to solve for x and y. So just like when we did congruent triangles, the sides on the diagonal that are on the same diagonal are going to be corresponding. So x and 4 are corresponding sides. 10 and 5 are corresponding sides. And 15 and y are corresponding sides. So in order to solve, we're going to use 10 over 5 both times because they both have numbers, so we can eliminate the worry of having two variables in our problem. To solve for x comes from the triangle with the 10, and 4 comes from the other triangle, so we have x over 4. So when we cross multiply, we get 5x equals 40. We can divide by 5 and get that x is 8. To solve for y, We have 10 over 5, and we're going to set it equal to 15 over y. So when we cross multiply, 10y equals 75. Divide, and we get y is 7.5. So to find our scale factor again, remember it's the new triangle over the old triangle. So in this case, the side from the new triangle, IEL, is 5. The side from the old triangle is 10, which reduces to a scale factor of 1/2, which should make sense because all of the numbers in the first triangle are bigger than the numbers in the second triangle. So our fraction should be less than 1. Number 3, write a similarity statement to state why the triangles are similar, then solve for x and y and find the scale factor. So in this case, again, we have congruent vertical angles, and AB is parallel to DE. So we can say that A and E are congruent because they're alternate interior. You could also use angles B and D. So we would say that triangle ABC is similar to triangle EDC by angle-angle similarity. So again, in this case, I'm going to figure out which sides correspond. So 5 and 6y minus 9 correspond because they're on the same diagonal. 2 and 6 correspond because they're on the same diagonal. And then our vertical, our parallel lines are going to also correspond. So in this case, we see that 2 and 6 are the sides with the same numbers on them. So we have 2 over 6 and 2 over 6 that we're going to use twice to solve for x and y. So to solve for y, we would put 5 over 6y minus 8, or minus 9. And we're going to cross multiply. So we get 2 times 6y minus 9 equals 30. We're going to distribute the 2, so 12y minus 18 equals 30. Add 18 to both sides, so 12y equals 48. Divide, and we get that y is 4. To solve for x, the side with the x in the first triangle is x plus 3, and the side with the x in the second triangle is 2x plus 13. So when we cross multiply, we get 2 times 2x plus 13 equals 6 times x plus 3. When we distribute, we get 4x plus 26 equals 6x plus 18. We can subtract 4x from both sides, and we get 26 equals 2x plus 18. We can subtract 18 from both sides, and we get 2x equals 8. When we divide, x is 4 as well. Then to get our scale factor, remember that the scale factor is the new over the old. So the second triangle listed has a side of 6. The first triangle listed has a side of 2, which reduces to 3 over 1. The other thing we're going to look at is what happens when we draw an altitude inside a right triangle. So when we draw an altitude from a right angle of a right triangle to the hypotenuse, the 3 triangles formed are going to be similar. So in this picture, we actually have 3 triangles. We have triangle ABC. We have our smaller triangle, ABD. And we have the third triangle, BCD. So we're going to draw them all so that we can show that they are similar triangles. And in order to do that, we're going to first just redraw the big triangle and 2 other triangles that have the same orientation, so facing the same direction. So I have my first triangle. I'm going to label it the same way, A, B, and C. My second triangle, and my third triangle. So in the second 2 triangles, we know that the right angle changes to become D. Then we need to figure out the other 2 angles in each triangle. So the easy way to do that is we know that A has 2 tick marks and has to be at the top of the triangle, and C has 1 tick mark and has to be at the bottom of the triangle. When we go to draw our smaller triangle, so if I look at this triangle that's in pink, I notice that that triangle also has angle A in it. And angle A didn't change at all because there's not a line going through it. So in the second triangle, we're going to put A on the top, and we're going to put the missing letter on the bottom. Then to get our third triangle, in the blue, we see that angle C matches up with angle C from the yellow triangle. So it has to be in the same position. So we're going to put C in the bottom because the original triangle, it was also in the bottom. And then the missing letter in that triangle is B. So the easy way to redraw these pictures is just redraw your first triangle looking the same direction. In the second triangle, in the third triangle, label your right angle and label the angle that matches up from the original triangle, and then just add that letter that was missing from the third one. So number 5, identify the similar triangles and then use the similar triangles to solve for a missing variable. So I'm going to redraw my 3 triangles. Notice I changed the orientation of the triangles because of the picture. So I have the triangle A, B, C. B is our right angle. In the other 2 triangles, D is now the right angle. And then I know in the first triangle, that's the new triangle, that A matches up from the original triangle. So A is going to stay in the position it was, and the letter missing in this case is B. So B is going to be on the other angle. In the third triangle, which is the second little triangle of the picture, we know that they both have C, so C has to stay in the same place from the original triangle, and the other letter that's missing is B. So when we name our triangles, we have triangle ABC, triangle ADB, and triangle BDC. So if I want to solve for x, I need to label the sides of the triangles that I know from the 3 triangles. So I see that AD has a length of x. So I'm going to label AD in the pictures. BD has a length of 8. So anywhere I see BD, I'm going to label it with 8. And CD has a length of 4. So notice that in 2 of the triangles, we have 2 of the corresponding sets of sides labeled. So we have x and 8, and we have 8 and 4. So we're going to use those sides to set up our proportion. So we have x over 8 equals 8 over 4. We can cross multiply, 4x equals 64, and divide, so x equals 16.